Hello guys, welcome to Mathphile, and this is the third video for the integration sessions. So in this video, the objective is very simple. We're going to learn how to integrate functions in the form e raised to the power ax plus b dx. This video should take me less than 3 minutes or 5 minutes to finish up. Yes, so previously we learned how to integrate the power function, that is when you've got x raised to the power n dx, and we just add 1 to the exponent and divide by the new exponent plus c. I would advise you to watch the previous video if you've not done that already, which we extended the knowledge to integration of the form as plus b all raised to the power n, which is the same thing, but the only difference is that with this one, after doing the integration, we multiply by 1 over the differential of what is inside. And again, I should repeat that these integrations are limited to additional mathematics, that is for IG and O level. We are not looking at when the exponent is more than 1 basically, and this, if you have to go into details, is called a U substitution, but there is no need to make mention of it at this stage. Now for starters, we learned that integration basically reverses differentiation, and that if we've got integral of, let's say, 3x squared dx, you don't really need to do or go through the process of the integration. If you know the function that when you differentiate you're going to get this, you are good to go. So this is asking you which function would you differentiate to get 3x squared. So in this case, if you know this of it, I know that when you differentiate x cubed you get 3x squared, so the answer is going to be x cubed plus c. You can check this one by using the power rule, by adding 1 to the exponent. If you add 1 to the exponent, it's going to 2 plus 1, which is 3, divided by the new exponent, and this simplifies to x cubed as well. So you can save yourself this trouble if you know the function to differentiate to get 3x squared. Similarly, if you come across, let's say, with 4x raised to the power 3, I can see that the answer to this question is basically x raised to the power 4, because when you differentiate x raised to the power 4, you get 4x raised to the power 3. So which function would you differentiate to get whatever is inside the integration? That is the main thing you need to pick up from this. So let's start with the exponential function. So y equals to u raised to the power x, integral of u raised to the power x dx. Again, the question is which function would you differentiate to get e raised to the power x? And the answer is very straightforward. It's e raised to the power x. So there is nothing to worry yourself over when it comes to the exponential function. So this is e raised to the power x plus c, just to cater for any constant that comes with it. So we're saying that if I give you y equal to e raised to the power x, and I tell you to find the y dx is simply e raised to the power x. Also, if I give you y is equal to e raised to the power 4x plus 5, for you to differentiate this, there is going to be the y dx to be equal to e raised to the power 4x plus 5. Now you multiply by the differential of what is on top. Now the differential of what is on top is 4, leaving you with the final answer as 4 e raised to the power 4x plus 5. So let's extend the knowledge to integration. So let's say we've got y is equal to e raised to the power 3x plus 2 dx. And to integrate this one, because it's an exponential function, we say that the answer is going to be the same thing inside the integration, e raised to the power 3x plus 2, with a little bit of a catch. With this one, you multiply by the differential of what is on top. That's the 4 you can see over here. But with the integration, we're going to multiply by 1 over the differential of what is on top. So the differential of what is on top is 3, leaving me with the final answer as y is equal to 1 over 3 e raised to the power 3x plus 2 plus c. So the integration of exponential functions in this form is pretty straightforward and nothing to worry yourself over. So let's take more questions. Let's say we've got y is equal to integral of e raised to the power 5x minus 2 dx. So we say that the y is going to be equal to e raised to the power 5x minus 2 multiplied by the integral of differential of what is on top, 1 over the differential, and 1 over the differential is 5, giving you y is equal to 1 over 5 e raised to the power 5x minus 2 plus c. Now another example we can look at will be, let's say y is equal to integral of 7 e raised to the power 2x plus 5 dx. So you can pause the video and see if you can try this by yourself and come back in our 30 seconds. Okay, welcome back. So with this one, you can say that y is equal to, the entire thing is 7 e raised to the power 2x plus 5 multiplied by 1 over the differential of what is on top, then plus c. And y is going to be equal to 7 over 2 e raised to the power 2x plus 5 plus c. So that's the differential of exponential functions, and that would end today's lesson. In one of the videos, we will solve more complicated questions. This video is just to expose you to how to integrate exponential functions. So in summary, we can say that when you've got y is equal to integral of e raised to the power ax plus b dx, then we can say the answer to this is going to be e raised to the power ax plus b repeating itself, then multiply by 1 over the differential, so 1 over a plus c, and that is the integration of exponential functions of that form. So let me just put a nice box around it. Okay, so that'll be all for today's lesson. See you in the next video.